Janani, are you there? I think you're muted.
I'm sitting and talking at the muted microphone.
Excellent. Over to Janani once again.
Thank you for the introduction and getting us all in the mood, Siddharth. Lovely to see so many of you here in the masterclass, and we are so excited to get into it. So I have a real fun time working with Siddharth and working with all of you. We have a really interesting job, which is to get fascinating students like all of you to meet amazing mentors like Kanchana, right? And we have these lovely conversations. So let's jump into it. If you're new here, Gifted World is this online community where we can meet each other, have interesting conversations, find lots of fascinating things to learn, and have connections and meet peers who are also really interested. So if you've not seen it before, this is giftedworld.org, and you can look at our upcoming masterclasses like this one. You can look at the online courses that we have, and you can do a lot of fun stuff together. So I'm going to introduce Kanchana, and she's going to get us started for today, right? Kanchana is an amazing mentor, and I've had a really fun time listening to her plan this masterclass. And usually we think about math as just numbers, and some of our Gifted World members, think about math as numbers plus shapes and designs and various other things. Some of you have been working with our previous math courses, and you thought about maths in terms of a weighing scale, a whole bunch of things. But today, Kanchana is also going to introduce us to math and tech tools, and I'm excited about that. Right. Kanchana has been an educator for the past 10 years, and she actually trains teachers. She trains other people to make math learning fun and really connect to your life and to the real world. And before that, she had a whole life as a software engineer, and I think this is a fun, small meeting of those two spaces. So over to Kanchana to take us forward. Just a quick reminder, 3 rules. Let's be respectful of each other in the chat and otherwise. And because we have a large number of people here, if you want to say something, raise your hand. If we get a chance, we will unmute you. There's going to be places where Kanchana will ask you questions. Please put your responses in the chat so that we're not all talking over each other and we have a chance to hear what Kanchana is saying. Yes, was that the 3 rules? Yes, cool. Okay, all right, over to Kanchana.
Thank you so much, Janani. Like Siddharth and Janani pointed out, I'm so excited to see so many people as well. It is so awesome to see all your expressions and your comments. This is very exciting for me as well. So today's session, some of you wanted to know what the topic is, right? So we're going to look at developing a certain flavor, developing a certain sense of what algebraic thinking is, right? It's not going to be algebra like you will learn in school, but try to develop a way of looking at patterns, whether they are number patterns or geometrical patterns, and see how you can think of them from another perspective, right? How you can figure out a language to talk about them. That's what we're going to look at today. We will start with something that you're already familiar with, some simple math games. Maybe some of them you've already done before, right? We will start with something simple and easy and familiar. We will use a digital tool. We will use spreadsheets to look at the same thing, something that you're familiar with, but from another angle. And then we will quickly step it up to see how we can use spreadsheets to look at even complex patterns, right? So be ready, stay focused, and so that you don't lose out on the in-between steps. And at any point, if you have any questions, please make sure you type it out into the chat, right? Let's start off. Please take out your pens and pencils and papers, right? I hope all of you have paper and pen in front of you. Let's get started with a simple math game, right? I'm going to get you to do this maybe 2-3 times. So you can write down the instructions if you want as I call it out as well. So start off by thinking of a number, right? Any number, think of a number, yeah? And then go ahead and add 3 to that number. Yeah, if you all want to write this down, go ahead, or you can do it in your mind as well. Double the answer that you've got. Right? You've added 3 to the number. Whatever number you have, double it. That is multiplied by 2. Then add 4 to your answer. Yeah. Then whatever you have now with you, divided by 2. That is, you're making it half of what it is. Yeah. And then finally, whatever number you thought of first, take away that number from your answer. Okay, if I went too fast, quickly recapping, I thought of a number, I added 3 to it, I doubled my answer, then I added 4 to it, then I made it half, and I took away the original number. Can you type out your answer on the chat, please? What did you guys get? Ooh, ooh, ooh. Oh my. Isn't this something strange? I wonder if all of you thought of the simplest number that you could think of, right? Maybe I want to add a constraint. Give us a minute, anyone. Let's work this through a little more. I would like you all to make this a little more complicated, right? Think of some different number type, right? Let's think of a fraction. Maybe you think of a number like 3 by 4 or 5 by 17, right? Or you think of a decimal number. It could be small, it could be big. Maybe you think of 7.8. And let's do the same thing again. Okay, so what am I going to do? I'm going to go back and walk you through this. But this time, I want you to have thought of a more complicated number, a fraction or a decimal. So start off with a fraction or a decimal. Add 3 to it. I'm assuming it'll take us a little longer. Multiply this by 2. That is, you're doubling whatever you got. Yeah, I hope your number is complicated enough, huh? Nothing simple. Add 4 to it. Now divide it by 2. Let's make it half. And finally, whatever complicated number you thought of before, remove this from your answer. Now I want you to type out your answers again. Let me see what you get. Ooh, Lakshmi says it's silver. Again, we have this rush of 5s. Yeah? I assume there's a typo in between, but oh my goodness, oh my goodness. Okay. Can someone tell me what is happening here? Why do you think, since there are so many of us here, yeah, so many of, oh, I see a lot of hands going up. I see so many of us typing out 5. I'm sure all of us don't have the same number, right? Okay, there are some answers coming up as well. Could you type this out in the chat, please? What are you thinking? What do you think is happening here? Oh, I think I'm going to need Siddharth's help or Janani's help. It's going up too fast for me to quickly read what's going on. Do we want to call on somebody maybe?
Yeah, so let's
Is
call
that
on
simpler?
Spandan.
Okay,
Let's
okay,
call
go
on
ahead.
Spandan.
Spandan, could you tell me what is going on out here?
Now actually, if we take a variable x and then add 3 to it and double it, we'll get 2x plus 6. If we add 4, we get 2x plus 10. If we halve it, we get x plus 5. So if we take away the original number x, we are left with 5. So if we do it the way of algebra, then we'll get 5.9.
I think we should swap places. I think Spandan should be taking this master class. But thank you so much. That was very clear, very lucid. Anybody else? What do you think is happening here? Something other than the way Spandan voiced it out. How would you think about it? Can I have another answer?
Anagha, we will invite Anagha to unmute.
Okay.
Like the number you started with, in the end it's subtracted, so both of them like almost get cancelled, I would say. 3 into 2 is 6, 6 plus 4 is 10, 10 by 2 is 5, so you'll always get 5.
Very nice. Thank you so much. So Anagha had another way of looking at this, right? She looked at the steps I've written out and she said, you thought of a number, but at the end, you're going to take it away. So that's going to go away. You started with 3, you double 3, you get 6. Then you add 4, there is 10, and then you have it. So at any point of time, you're going to have just 5 with you. Can we take one other answer? But please make sure you're saying something different, right? One more, and then we will move on. Whom do we call up?
Mian put his hand up.
Yeah. Okay. Vihan?
Go ahead.
Can we invite Vihan?
Yeah.
So my answer is they are multiples of they are divisible by 1. So this calculation, add 3 double, add 4 half, is equal to every number. Every number that you think of is going to answer the same.
So if I take another number, Vihan, if I did not take
Yes.
3 or 4.
Even if you took another number as a decimal, the answer will be same.
But can you explain to me what you meant by they're all divisible by 1? Which number is not divisible by 1?
No number is no number is not divisible by 1. Every number is divisible by 1. 27 divided by 1 is 27. So
is there something, so if I did not have these steps, if I change the steps, would it still work? Would it still always be 5 that I have?
No, if you change the steps, then it would be something different for anybody else.
Okay. I'll stay with that thought, Vihan, because I want to look at this in two different ways, right? One of them was already called out, but I want to first start looking at this through shapes. Some of you had answered the shape puzzle that was sent out to you through email as well, right? So let's imagine this through shape. This is a little similar to what Anaga mentioned. I'm going to imagine my number as some shape, right? Here I've taken it to be a rectangle. Yeah, so I'm taking it to be a rectangle, whatever that number might be. I add 3 to it. Notice how I've shown it as 3 small, probably oval coins, right? When I double it, what am I going to do? Instead of 1 row of these numbers, I'm going to take 2 rows of these numbers, right? So I'm doubling it. Then I'm going to add 4. When I add 4, do you notice what I'm doing? I'm adding 2 to each row. So it continues to be symmetrical. So I'm adding 4, but I'm adding 2 to each row, correct? And then I go ahead and do a half of it. By half, what do? I have 2 rows. So I'll just go back to having 1 row of my numbers. Then I'm taking away the number you started with. So the number I started with is a rectangle. I'm going to take away that rectangle. What am I left with? Just the 5 coins that I've added. Yeah. So I think this is probably what Bihan was trying to say, if I've understood him correctly. And this is what Anaga was trying to say as well, right? That we have taken something and then we're taking it away. We're adding something, we're halving it. This process helps you understand, even if I don't have a number in my mind, what is going on, right? Let's go back to the other algebraic solution that we got at the beginning. Instead of a rectangle, I say, let's use the language of algebra, which some of you might be familiar with. Don't worry if you're not, because we can continue to use figures as our crutch, right? So let's take some number, we'll call it x. We will add 3 to it, and I will show it as x plus 3. When I double it, what is happening? The x becomes double, so it becomes 2 times x. The 3 becomes 6. So I have 2x plus 6. Then I add a 4. I've already added 6 and I add 4. That means I'm adding a 10. So it becomes 2 times x plus 10. If I'm going to make this half, the 2 times x becomes x again because you're dividing 2 times x by 2. The 10 becomes 5. So I have an x plus 5. And finally, if I'm taking back the original number that I had, that is, I'm taking away x, I'm left with my 5. Yes? So I think a lot of you had a sense of what is going on. I saw a lot of hands raised. So it is not that the solution might be a revelation, but what I'm trying to urge you to do is look at the way we are thinking about this, right? It's not about the answer in particular, but what could have led us to come to this answer. I want you to pause a little bit and think if something could change if I thought of a different kind of a number type. If I thought of a negative number, for example, would things change, right? We also have more complicated number types going forward. But if I change, for example, it to something called an irrational number, I don't know if you're familiar with it, but say a number which does not have a whole number square root. I thought of a number like root 2. Will this change? Or if I change some of my steps, instead of saying add 4 in the 4th step, suppose I said add 17, will this still work for me, right? So I want you to think of some of these. I will pause for a bit, and the pause is so that you can actually note down if some of these strike you, right? If something can change, if I change some of the rules or a number type. But if you've totally understood what is going on, I would like you to create a small puzzle for yourself. Let's just take a quick half a minute to do this. Yeah. Think through and see if you can create your own number game, number puzzle. Hold on to it and we will figure out a way to test it through the masterclass, right? So I'm going to give you just half a minute for this to pause and reflect. Okay, so hold on to your thoughts, hold on to your puzzle. Let's move on. We are warmed up, I think. We have a sense of where we are headed now. So I would like us to try out yet another one, right? Another game. Okay, so let's do this. I would like a volunteer to play this game with me. Okay. Yes, whom shall we call on?
We're going to invite Kabir.
Okay. Kabir, you ready?
Yes, ma'am.
Yes, okay. So let me read out the rules of the game for you, and you can help me play this, right? It starts off by saying choose any two-digit number. So choose anything. Yeah.
Okay, chosen
Yes.
it.
Okay.
Should I tell you what number I've chosen?
Yes, we'll play this together to see what happens because the machine does not know what we are thinking, right? It can't understand. So you go ahead and tell me what number you've thought.
79 watch.
79. Okay, awesome. So let's take 79 and it says add the two digits together.
So
Add up 7 and 9.
7 plus 9, 16.
Very nice. The next step is subtract this number that you got from your original number.
Original number?
79 was your original number.
Oh,
You added up and you
79
got 16.
79 minus 16.
Correct.
That would give us 63.
Okay, let's look at 63. What is the symbol next to 63? What does that look like? Do you think it's a brain, a pink brain? What do you think that is?
Let me find it. Yes, it's a brain.
Okay, so keep this in your mind. We got a pink brain as an answer. Okay, now I'm going to click and see whether the machine can guess what is it that I have got. I love it that it's pulling all of them together, mixing it up. Let's see what comes out of this. And yes, it got the pink brain out. Yes, can I have one more volunteer? Let's play this one more time. Thank you so much, Kabir. But I'd like you to think about what's happening.
How
Kabir?
did this happen? This is
Yeah, that's what I want you to think
Let's
about.
invite Atiksh.
Okay, Atiksh, shall we try this together again? Atiksh,
Yeah.
some other number?
Yeah, and ma'am, I think I know this trick, but like I'll
let's
tell it to you
wait.
later on. Okay.
Yes,
okay.
thank you. Thank you.
Okay.
Tell me, which number shall we think about?
Ma'am, I would like to take 11.
11. Okay, simple one. Let's take 11, add the two digits together.
Which would be 2.
Subtract it from the original number, 11
Which
minus 2.
Which should be 9.
9. And the symbol for the 9 here is?
Heart.
A heart. Okay, let's see what the machine does. And tan-ta-dan! There you go. There's Atiksh's heart, right? But thank you, Atiksh. I'd like you to be a little patient with me in terms of giving people time to figure out what's happening. Janani, if you could just message the link to all of them. I'd like you all to go to the link that Janani is messaging you on the chat. Each of you, please try this out. Okay, try out and see what is happening. Is the machine able to guess you? Oh my God, so many hands up. Is the machine able to guess your number each time? Right? Try it out. I'd like you to try it out a couple of times. And once you do, I'd like you to think about what is happening and send me your ideas on chat.
So can we stop chatting for just like 30 seconds so that everybody can get the number, jump to the link, and then you can continue after that.
Participate in your thing.
One of you had messaged saying it got it wrong. Can you just go back to your calculation and try this one more time? Because I think the machine is doing quite a good job. I was not able to figure out a time that it was going wrong at all.
So Devna, just click the machine itself after you've done your calculation.
Okay. Now, any ideas on how this is coming out? Could you type it onto the chat, please? Okay. I think generally one of the children had an idea of why it was working each time.
Yeah, so we've had a couple of theories. Let me read them out. Vinay says every time it comes to a particular emoji, okay, and a popular emoji is what was the other idea. Seem to see it often. Says they are multiples of 9. And a couple of people feel like they've beaten it. Not sure how. Those were the. Inian has seen this before, and he says all the possible answers are multiples of 9 and have the same symbol.
Okay.
Berry says, I think it is because there are so many of one symbol, so it just picks randomly. Aryan feels AI is listening and seeing our eye movements.
I love that one. I love that one. It's good to watch out.
Vishan says, eye tracking. And I read so many answers coming in.
Okay.
And then says it should be 9x spawn. AI has risen. I chose the number 0 and it came out wrong.
Did it? Okay. Okay.
Am I missing anything else to that?
I'll give one. That's giant. Any number minus the sum of its numbers.
Any number minus the sum of its number is always giving a factor of 9. Every emoji with a factor of 9 has the same symbol.
Multiple of 9. Yeah, got you. Very nice. Very nice to see all the guesses and the fun answers as well. Now let's try to look at this problem, like I said, in an algebraic way, right? Let's look at the pattern. Let's try to understand what is going on and see whether it can give us a solution to what is going on, right? So to understand what is happening here, let's start with an example, right? Like some of the children worked it out with me. I'm going to take an example. Let's take the number 37. Okay. Now we all are familiar with the place value system. When we see 37 itself, automatically we know what that means. It means 3 is in the tens place, 7 is in the units place. So we know we say 10 times 3 plus 7 gives you 37, right? Now I have this number and I've broken it up like this for a reason, because I'm trying to figure out what is going on behind the screen. Then it's asking me to subtract the sum of the two digits, right? So I have to subtract 3 plus 7 from it. But I notice the way I've written it out, I'm adding 7 and I'm going to subtract 7. So let me make my life easier, right? So let me subtract the 7 from the 7 and the 3 from the 10 times 3, right? This makes my life simple. I don't have to add and then subtract. So 7 minus 7 gives me a 0. I now have 10 times 3 minus 3, right? Now, whenever I have, let's look at the 3 times table, right? When I have 10 times 3 and I subtract 3 from it, what do I get? I get 9 times 3, don't I? So if I take any numbers, the times table, let's take 7 times, right? 10 times 7 minus 7 gives you what? 9 times 7, correct? So let's look at why I have looked at it in this particular pattern. Does it make sense to me, right? So I'm going to quickly go over this again. I took the number 37, broke it up into its parts. I said 37 is nothing but 10 times 3 plus 7. Now I have to remove 3 plus 7 from it. So I take 7 away from 7. So I say 10 times, I'm left with 10 times 3 minus 3, which is nothing but 9 times 3. Why did I do this, right? Let's try to see what happens if I assume I don't know the number. It could be any number, which is where I'm going to start using the language of algebra again. I don't know the digits, so I don't know what is in the tens place. I don't know what is in the units place. I'm going to assume it's x and y. Okay, so I'm going to write this as 10 times x plus y. I did a little bit of shortcut here, a little bit of cheating. In algebra, you can write 10 times x as 10x, just to make it simpler to look at. So I'm writing 10 times some number in the digits, in the tens place, plus some other number in the units place. I'm going to subtract the sum of the two digits, just like I did for 37. So I'm doing 10x plus y, and I'm going to subtract x plus y. So again, I notice I have a plus y here, and I'm going to subtract a y. So let me take a shortcut and do y minus y. So I'm left with 10 times x minus x. What does that mean? It is going to be 9 times x. So no matter what two-digit number you're going to take, ultimately it's going to come down to be a number in the 9 times table, like quite a few of you pointed out. So if the machine can make sure that any number in the 9 times table has the same symbol, it doesn't matter what number you guessed. It's always going to get that symbol right. Yeah. So when we work out something like this, I know some of you said, no, I cheated the machine, or I got a number wrong, or I got a different symbol. You get a sense of why I said, Nana, go back and check your calculation. Because I have now shown, using algebraic pattern matching and thinking, that no matter what number you have, it has to come out as a number in the 9 times table. Yeah? Okay. So, let's continue, because I want to keep the rhythm of this, right? Let's move on. Before we take a pause, right? I want us to, I think one of the, Krishna, are you facing a challenge? Maybe you can put it up in chat. And Janani, okay, you're good. Okay. So what we've looked at so far is we've looked at multiple numbers, tried to look at patterns, tried to see what is going on. And some of you already used the language of algebra to look at it. I want to introduce you to a new way of looking at this, right? We will use, in today's session, we will use spreadsheets. I think you already might have got an email. It is okay, whichever one you use. If you have access to Microsoft Excel, open it up right now. Or if you have access to Google Sheets, you can open that up either, right? Either of them is fine, because the instructions that we're going to work on will work on both of these. So go ahead, open this up. Let's try to look at the same two problems using spreadsheets and see whether they help us with this pattern. I'm going to open up Microsoft Excel. Those of you who are going to be working with Google Spreadsheets, on the top right, you will see a share button. You can go ahead and click on share, and maybe share it with janani@genwise.in. Janani will just type out her email ID so that we can see what you're doing and what is the work, what different patterns you come out with. Those of you who are working with Microsoft Excel, you can email it to us once you're finished with it, right? We'd love to see what patterns you're coming up with. Are you coming up with a new game? Do you want to test your game, and so on? Okay, so I hope all of you have got your spreadsheets up. Can we do a quick hands up so we know if the bulk of you, those of you who have hands up for questions, please put it down now. I want to get a sense of if most of you have got your spreadsheet open, right? A quick thumbs up or a hands up to see. I see quite a few of you. Yeah, I think we are good there. Okay, let's get started. Okay. So what I am going to do is the games that we worked with. We'll start with the first game, right? Now, when I am working it out, I can work on 1, 2, 3 examples maybe. There was an advantage having so many of you in the class, right? Then I can look at so many answers at one shot. But if I'm working on my own, let's see if the spreadsheet can help me do this. I will start off by thinking up a list of numbers. I start off, let's say, I'm just going to say your number in the first column. So you know what is it that I'm going to type out here. I will start with the number 1. So you can just type in 1. I want to first very briefly, for those of you for whom spreadsheets, this is the first time with spreadsheets, there is a way that spreadsheets understand which cell you're clicking on, right? Which rectangle you're clicking on. On the top left, if you notice, it says A3. Now, each of the columns have a name. These are the letters of the alphabet, A, B, C, D, E, F, and so on. And each row, the horizontal rows, have numbers against them. 1, 2, 3, 4, and so on. So if you notice the cell that I've clicked on, it's called A3. So this is a way to uniquely identify a cell. by the name of its column and the name of its row. Okay, so this is what I'm going to use. It's like a variable in algebra, right? Now what I'm going to do, I'm going to first click is equal to. Is equal to is the way you're telling Excel that I'm going to type in a
Kanchana,
formula.
sorry to interrupt. Can you
Yes,
set the
Janani.
zoom to be higher?
Sorry, say that again, please.
Zoom in Excel.
Can you set the zoom in your Excel to be higher?
Oh, okay, okay.
Under
Sorry.
view, I guess.
Bottom right.
Okay.
Bottom right, bottom right.
Just one
There's
second.
one
I'm trying
that
to
says
do it.
100%.
Yes, I'm trying to do it with my finger, which is not working, but hold on a minute. I don't see it changing.
Right now you are in a cell in.
Just one second. Give me a minute. Sorry about that. I don't think the cell. Okay.
Yes.
Okay. Yeah. Awesome. Sorry.
Thank
Is
you.
this better? Is this better?
better,
Okay. Okay. Thank you. Okay. So what I'm going to do now is I'm going to say is equal to, and I'm going to click on this first cell, which is A2. Get back to my cell and say +1. You can type this directly as well. You don't have to use your mouse. You can say is equal to A2 +1. And when I say enter, it automatically does the calculation for me. Because right now, A2 has the number 1. So A3 is equal to A2 +1. You will see the formula coming up at the top right here. And it's automatically doing the addition. Now, why am I doing this? Because I now want to have huge number of numbers that I'm trying this out with. So here we come to the magical part. I have the cell clicked. Let me move my mouse to the bottom right. Your cursor should become a small plus sign. I'm going to click on that plus sign and I'm going to drag. Okay, let me drag to maybe 50. Yeah, somewhere, right? If you notice what is happening, it is automatically copying the formula for me. And it is automatically filling all these values for me. So I now have 1 to 50 something odd number already created for me. Yeah. Don't worry in case it's going a little too fast. At the end of the session, I'm going to be sharing my spreadsheet as well with you. But quick recap, I typed in the number 1 in the cell A2. And in A3, I said is equal to A2 +1. Bottom right, I got this cursor down, I got a plus, and I dragged it down all the way to multiple cells, and all of them automatically got filled with the numbers that I want. What was the second step? I was going to do an add 3. Yes? So I say is equal to again, because I'm going to type in a formula. And I'm going to say whatever was in this cell, I'm going to add 3 to it. Okay, so look what I have typed down. I've said is equal to whatever was in A2 plus 3. It does the addition for me, and I'm going to do the same magical autofilling. I go to the bottom right of the cell and I drag. So as I click and drag, and when I finally release it, you will notice all the numbers are getting filled, right? So it's done the addition for me. And what was the next step? If I remember right, it was double it, right? So I'm going to say is equal to, take whatever number was in the cell to its left, and I'm going to say into 2. In Excel, in spreadsheets, the multiplication sign is the small asterisk sign that you find above the number 8. Yeah, so shift 8 should get the multiplication sign for you into 2. So I say B2 into 2. Again, click the cell, drag it down. It does the multiplication by 2 for me. I think we had 2 more steps to go. The next, no, 3 more. I'm going to add 4. Again, is equal to, take the number to its left, plus 4. Choose my cell, bottom right, drag it down. Okay. Steps, I think I had to halve it. That is, I'm going to take the cell to its left, and I'm going to do divided by 2. Divided is a forward slash by 2. Again, I choose the cell and I drag the bottom right down. Okay. And the last step for me was to take away the original number. Yeah, I was going to take away your number. So what will I do? I will take the number to my left. I will say minus and select my first number. So from E2, which is your final answer, I'm taking away A2, which was your original answer or original number. And now, again, select the cell, drag down. And this is where we start seeing the pattern. We've done none of the calculations. Excel has done it for me. And I see no matter which number I choose from 1 to 60 or 1 to 50 odd number, when I perform these operations on it, all of them give me a final answer of 5. Yeah. In fact, what is interesting is I don't have to start at 1, right? Let's say I take another complicated number. Let's say I do 0.75, right? You notice what happened? Excel automatically changed all my calculations, did all the add 3 double, add 4 half, etc. Everything changed, but my last column of my final answer continued to be 5, which tells me that it doesn't matter what number I took, even if I take a decimal number, this is going to work for me. You can try this with different number types as well. But what I want to point out to you is the advantage of doing this on spreadsheet is I don't have to work out 5, 6, 10 numbers to figure out what could be happening, right? Because you're not spending time on the actual calculations, which I'm confident you all know how to do, but more on analyzing what is happening. You start playing around with it and say, does this work? Would it work in this condition? Instead of adding 4, like the questions I asked you, if I did an add 17, would this work for me? You just have to change your formula and figure out what happens to the answer, right? So let me pause here for a bit because I know where I went a little fast. Jenny, if you could do some sort of a mood check to see where people are, if they were able to follow the instructions, whether they were able to try this out.
So Kanchana, just a quick, I've been looking at the questions. Some of the folks missed the last formula for the last takeaway, the column F.
Understood. Let me quickly show it to you. So in my worksheet, it is E2. E2 is the number right to its left, right? Mm-hmm. This minus the first number, which is A2. So I typed in is equal to E2 minus A2.
Great.
And then write it. Yeah.
That was.
Let me stop the share for a minute to get a sense of where we are.
Yes, I think that was the biggest question. Yes. We have a poll up, guys, just to check in, but I think, Kanchana, most of us are following along. A couple of people who may be having difficulty, but I think we will sort that out as we go into the next couple of steps.
Okay. So most of you are following on, then that is good. Then can I have a volunteer for the number jumbler then? If any of you who's got access to an Excel sheet or a Google spreadsheet and can do this with me for the number jumbler.
So put your hand up if you are on a laptop or a computer and you can do it. So can we call on Sridevi?
Yes, ma'am.
Okay. Sridevi, will you be able to share your screen, please, so I can see your spreadsheet? And let's try to work on the number jumbler together. Number jumbler was the second one that we did, right?
Okay.
Are you able to share your screen, Sridevi?
Yeah.
Awesome. Okay. Do you want to start with, the first column? You start with the number 1 and then go ahead and So in the number jumbler, how did we start off with? We said guess the 2-digit number. So you can probably start with 10, right? And then type in 10 in the first one. Yeah, 20, I mean, whatever, no problem. Now, what would you type in?
Sorry to interrupt, Kanchana. Sridevi, just press anywhere outside your cell for a second. Just click anywhere outside. Yeah, and then you see the number 100% up there? Press that. Yes. And go to 125, please. Great, thank you. Okay, back to Kanchana.
Thank you so much. Yeah, what would you type in A2, Sridevi? A2 is the cell right below. What would you?
0.
So 10 is already in A1. You want 11 in A2, isn't it? You want 11, 12, and so on, all the way up to 99, right?
Yeah.
So what would you type in A2?
A2 is equal to A1 plus 1.
Very nice. Go ahead and type that out. Say is equal to, so you're telling Excel, yeah?
E1.
1. Excellent. Go ahead and say enter. Okay, now I want you to click on A2. Yes, go to the bottom right. Yes, now drag it down till maybe 90. Like, I think if you hit 90, you should have hit 100 because we started at 10. Super. Let it go. Areva. Very nice. Let's scroll up to the top. I find this the most exciting. No matter how many years I've worked with Excel, this autofill feature is by far the coolest feature ever. Okay. Now, in the number jumbler, what did we do? We had to subtract the units and the tens digit value. Okay. Now, this is a little tricky here because I don't want us to do all the calculation. I want Excel to do all the calculation, right? So can you tell me, if I give you a number 10, how do I get that 1? How do I get Excel to calculate what is in the tens place?
You can put is equal to 1 plus 0.
But 1 plus 0 has no connection with the number 10 there. Suppose you said 1 plus 0, for example. The number 1 would appear for B1. But then would you do the same thing again for 2? So, for example, all your double digits which started with 1, your 1 plus 0 will do the magic. It will put in the number 1, which is no different from us entering the number 1 ourselves, right? But once I go to the 20s, you'll have to change your formula. You'll say 2 or 2 plus 0. And then once you go to the 30s, you will say 3, 40s, and so on. So that means either you are sitting and typing out n digits, or you're typing in whatever formula that works only for 10. I want you to think of a way. It doesn't have to be Excel related. If I was mathematically asking you to think of a way where, given a number, a 2-digit number, I want you to calculate such that the answer is the tens place of that number, how would you do it? We can get people to help Sridevi out. Can you type out your answers onto chat, please? And Janani, if you could call out a few of them, please.
Daivik says divide by 10.
Divide by 10, okay. What do you think, Sridevi? Divide by 10, would it work?
Because like for 11 and 15.
Yeah, what happens for an 11? Because Excel, unfortunately, does very good calculation. It would give me 1.1.
Yeah, it will give decimals. So.
Yeah. But we are heading in the right direction. Any other answers?
Divide by 10 and convert to integer.
So
convert to integer. Okay.
There was one. Spandan, I think, is.
Okay. If I convert it to an integer, I'm assuming you're saying something like a round off operation, correct? So if I take a number like, say, 26, and I get 2.6, and I'm going to round it off, what would I get typically mathematically? I would get, sorry?
3.
I would get 3, but I want 2, right? In this case. So you're all headed in the right direction. What we want to do is round down. I don't want to round up. Whether it is more than, whether it is 5 or more, the units digit, I always want to round down. So let's try this out, Sridevi. I want you to go back to B1, that cell B1. Yeah. Type in is equal to. And type out round, R-O-U-N-D. Very nice. And the rest of, no, go ahead. You're doing right. Not, yeah. And then DOWN. No, no space. No space. Yeah. Very good. Open brackets. Open the left bracket. This is shift 9. Very good. Now what you're going to type out is A1, right? So you can click on the cell to its left.
This one?
Yes, very good. You're going to say then / which should be with question mark for you. Or if you can type a /. Yes, very good. And say 10. So you're telling it, and then say comma and 0. And close the bracket, which is a shift 0. Let me tell you what we are doing here. We're telling it to do A1 divided by 10 and telling us to give us an answer with 0 decimal places. That's what this command does. Can you go ahead and say enter?
Yeah.
Now go ahead and do your dragging. Click on, okay, you're done. Awesome. You're already gone fast. Very nice. Can you quickly check whether it's giving you, it is doing the autofill for you. Excellent. Right? Okay. Do you notice what is happening? All good so far?
Yeah.
Okay. Now, how do we get the units digit?
Now we have to round up. So
if you divide by 10, what you're getting is something related to the tens place, isn't it? And if you round up, how is that going to help you? Let's take a number like 16. If I take 1.6 and round up, I get 2. What I want is 6. Okay, someone has a suggestion. A1 minus B1 into 10. Very nice. Do you agree, Sridevi? Devik says, I take whatever is in the first column. Okay, he says A1 minus B1 into 10. Can we try that out? Let's look at 12. 12 minus 1 into 10. That is 12 minus 10. What would it give you?
2.
2. Let's try another number, 28. 28 minus 10 into 2.
8.
8. Yeah, this works for us. Go ahead and type out that formula into C1 is equal to, select the first column, A1. Yeah, minus, that is, yeah, you will see minus the drop. Yeah, correct. And then select the next column, B1. And then we're going to do into, which is shift 8. 10. Type out the number 10 and enter. Let's see if it asks you for an autofill. Yeah, go ahead and say yes. Excellent. Can we double check? All going okay? Super. Let's now get to our last answer column. Let's go to the D top. What are we going to do now? What was the last step of the number jumbler?
You had to divide, subtract that number by the original number.
Correct. So what we will do is we can individually subtract the units place and the tens place, right? So let's say is equal to, let's take A1.
E1?
A1, the first cell, minus B1 minus C1. Yeah. So we've taken that number and subtracted the 2. Go ahead and say enter and autofill. Let's see what happens. Now, this is the interesting part that we've been waiting for. Do you see this pattern emerging? From 10 to 19, all the answers are 9. From 21 to 29, all the answers are 18, and so on. So every 10 numbers, things are changing, and they're changing in terms of, yes, Shivashri says, they're changing as a multiplication of 9, right? So for us to see this pattern becomes easier because we've got all the 2-digit numbers in front of us. We're able to see what is happening. It's easier for us to catch that 9 times table. Yeah? Okay. Thank you so much, Sridevi, for your patience. You can stop sharing your screen now. Yeah? Okay. So what we did now was we started off with a simple number puzzle that we could play and figure out what was happening there. We tried to use the language of algebra to explain it a bit, but more interestingly, and hopefully more newly for most of you, we tried to use digital tools to look at the same thing in a different way. What was the advantage of the digital tool? I'd like you to pause for a bit and try to think about what is it that it gave you as an advantage over working out by hand. I'm going to take a minute to give you a time to think about what was different when we used the digital tool. Note it down if you need to. Such snapshots of what we did in front of you if you need to look at.
Kanchana, should I read out some of the entries on chat to you?
Yes, please. Yes.
So no need of manual calculations, works faster, more reliable, increased efficiency. We didn't need to calculate, saved time, easy and quick, faster, more efficient.
Very nice. Thank you. Yes.
We have the concept of autofill.
Yes. What I want to point out was you're all absolutely right. We didn't have to do the calculation. The machine did it for us. But it's not because we don't want to do the calculation or don't know how to do it. This is simple enough calculation for any of us to be able to do. What we want to focus on is understanding the pattern, what is coming out of this, what is emerging, so we can ask questions on why rather than how. We're not spending most of our time doing the calculation. How do I calculate this? How do I do this? What is the answer? We're spending more time on figuring out why this is as it is, right? We're able to catch patterns more quickly because we're able to work with larger numbers. That is the advantage this particular activity is giving us, right? So we've started off with something simple. I want to pause here for a minute and do a quick bit of a check on how you guys are doing. Are you able to follow what we're doing? Were you able to follow what Sridevi and I were working out online? Can we do a quick check to see, please?
Yes.
Very nice. It looks like most of you are able to follow what is going on. That's good. And some of you are already ready for the next one. Very good. Okay, awesome. So we're in a good place. We can continue. We looked at numbers so far. I want to step this up a little bit and move on to geometrical patterns, right? So why don't we use the power of what we have learned to go to a little more different kind, I would say. Let's start looking at different kinds of patterns, okay? So we will start by making sense of a simple geometrical pattern. I will share this pattern I've created for you, right? It starts off with a small image, which seems to be growing, right? Each stage in this pattern seems to be growing as compared to the one before. I want you to look at it and see if you notice something that is a common connector between the two, or you're able to understand how we move from one to the other. Each shape that I've drawn out for you, there are 4 of them in this series, right? Each one is made up of tinier small squares, okay? So think about what is happening here.
So Kanchana, the response is square minus 1 or x into x minus 1.
Very nice.
N to the power of 2 minus 1.
Okay.
It's squared
like
minus 1.
Very nice. So it looks like a lot of you are familiar with both the languages, right? Okay, so the question for you is, would there be some image in this pattern which could have 99 squares inside it? Okay, a lot of yeses. Why 99? Someone is telling me 10 into 10 minus 1. Very good. Would it be the 10th picture, Lakshit? Think about it. Would it be the 10th one? But you're close. Yeah, 10 square minus 1. Very nice. What about 999? Would you have an image? Okay, 99, but not 999. Why so? Oh, 999 also is part of it. A lot of people are saying yes. Would there be an image with 999 squares in it? Okay, I'm getting a series of no's now. Someone said 1000 is not a square number. That's correct. 1000 does not have a square root. Yeah. Okay, can you spreadsheet one using fraction? I love that question. Thank you. You will go to spreadsheets. Okay, so you're all able to understand what's happening in this pattern, right? In the first image, what you see is like a bigger square of 4 with 1 less, right? You think of it as 4 minus 1. The second image, you can think of it as a bigger square with 9 squares short of 1. So 3 square minus 1. The next one would be 16 minus 1. That is 4 square minus 1, and so on. So when you think of a number like 99, it is nothing but 100 minus 1. And 100 can be written as 10 square minus 1, while 999 cannot be written as a square of a whole number. But the next number would probably be 100 square minus 1 if I asked you. If I asked you 9999, you would say, yeah, that works because it's 100 square minus 1. So you're able to see what is happening in this. Let us now step up and go to some more interesting shapes. Okay, so some of you might be familiar with this idea of fractals. Fractals are very fascinating as a concept, right? You do see a lot of examples. You might have heard of a lot of examples of them as well. I have just put in some images that I got from the internet. The first one is a sketch, I think, of a broccoli or a cauliflower. Second one is a very nice hand sketch of a tree. And the third is what is called a Sierpinski triangle. We will be exploring that today. I want to explain one particular idea before we move on. Most fractals have this high idea of self-similarity. What that means is if you take one small portion of it, and you zoom in, it actually looks like the entire figure. So if you take one stem of that cauliflower or one branch of that tree that you see, it actually looks like the bigger picture, right? It has this main trunk, branches from it, and further sub-branches and so on. So this is the idea of self-similarity. You take a smaller portion of it, it looks like the larger one, and so on. On the rightmost is what is called a Sierpinski triangle, right? It's named after the mathematician who came up with this. It's a very interesting figure. Let us dive in a little bit. If you all can pull out your paper and pencil again, I'd like you to understand how we draw the Sierpinski triangle before we start working with it. Okay? So how would we draw the Sierpinski triangle? I've started off with one shaded black triangle. If I marked the midpoint of each of the sides, just a second. So if I take the middle point of each of the 3 sides, this is an equilateral triangle that I have drawn. That is, all the 3 sides are equal. I now mark out the middle point of each of the sides and I join them. You notice I get another triangle. Imagine I scooped it out. I cut this out, which is when you would get the second figure, right? So from the first figure, I mark out the midpoint of the 3 sides. Imagine I'm removing it out or taking off the shading. I get the second figure on the right. And I continue to do the same thing. So let's take the second figure. I take the midpoint of the 3 sides. It's coming out looking quite... And then imagine I'm cutting this off. Yeah? When I do this, I actually get the third figure. And I continue in this series. You would get the next figure and so on. This is how the Sierpinski triangle is drawn. Okay? Now, what are we going to do? We are going to try to explore some ideas, some concepts of fractals looking at the Sierpinski triangle. Okay, let's start off by analyzing the number of black triangles that are getting formed at each step. Okay, so I'm going to call it in stages. I'm going to say the first one is stage 1, second is stage 2, stage 3, and so on. In stage 1, what do I have? I just have one shaded black triangle. Okay, so in my table down here, I've said the stage is 1 and I have one shaded black triangle. Now, once I draw the second stage, what do? I count the number of shaded triangles. In the second stage, I have 1, 2, 3 black triangles. Can you tell me, can you all type out and tell me what is happening in the next few stages? What number of triangles are we getting? Okay, Lakshit, you're saying it's 1 power 3, which is 1. 2 power 3. If I do 2 to the power of 3, wouldn't I get 8? Do I have 8 in the second figure?
I think Lakshit's conversation was part of some other chat.
Oh, I apologize. Okay.
Spandan onwards is talking.
Okay. Sorry about that. Okay, the next would be 9. Okay, and someone says 12. 3 squared is 3 times 3. Okay, then 27. Okay. There are some answers of 12, but I'm getting powers of 3. Very nice. Okay. Let's go back to our figure. So if we just go ahead and count it, right, you will go ahead and get, like someone pointed out, powers of 3. Because what is happening? Each black triangle is actually getting broken into 3 smaller black triangles, right? I'm not looking at the white. I'm only looking at the shaded ones. And the same pattern is repeating. That means at each stage, if I take the previous number of triangles I have and multiply it into 3, I'm going to get the next one, right? I'm also going to write out this. What is on the rightmost step? Again, it doesn't matter if you don't understand the notation that I've put in. I'm trying to figure out, given any arbitrary number, if I say, tell me what happens in stage 57, for example, are we able to capture it? There are different ways we can do it. One way of saying is, tell me the number which is in stage 56. I will multiply it into 3 and get the number in stage 57. That's one way of doing it. Another way of doing it is looking at some patterns, right? I can look at 3 here and say, oh, this is nothing but 3 to the power of 1. And what is 3 to the power of 1? It is, one second, to annotate. Okay, so I can write this as 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, and so on. Try to get a link between the power and the stage. This leads me to say, nth stage would be 3 to the power of n minus 1. Okay, this is one way of generalizing. I want to continue to explore this because my main goal is to go back to my spreadsheets. Let's look at this a little more. I might step up my pace a bit, but you can go ahead and type out your doubts, questions, etc. on chat. I want to now look at how the area of the shaded region and the perimeter of the shaded region behaves. Okay, so what I want to do is try to understand. I have filled in the first 2 stages for you. I'm going to take it, it doesn't matter what the actual value of the area is. I'm going to say, let's start assuming that the area of the big first stage triangle is 1, right? 1 unit square, right? Because what I want to see is what happens to the area. If I move to the second figure, you notice it is broken into 4 equilateral triangles and 3 of them are shaded, which tells you that the original area is broken into 4 parts and you're taking 3 out of those 4 parts. That means your area is going to be 3 by 4 of what was there in the previous one. Okay, let's go back and think about what is happening in stage 3, 4, and 5. Any answers? What would happen in stage 3? Okay, 3 by 4 to the power n minus 1. Thank you, Shravana. 9 by 16. Okay. Nice. Multiply by 3. Okay. Okay, good. Awesome. So some of you are getting the pattern. What is happening here is each time at every stage, I'm going to be multiplying the previous stage. 3/4 of it is what I'm taking away, right? 3/4, if you all notice, is less than 1. So what is happening at each stage? You're reducing the area of the black triangles. And you can see this happening visually as well, right? You see as you're going from left to right, the amount of black that you see on the screen is reducing. So you do understand this is because each time you're taking only a portion of what was there in the previous triangle. What is happening with respect to the perimeter? I want to explain. I mean, you all know what the perimeter is. But very colloquially speaking, it means I'm walking on the sides of all the shaded triangles, right? So let's assume each of the sides is of side 1, right? So if I take this first triangle, this is 1, 2, and 3, which means if I'm walking along the sides of the 3 sides, I get 3 units is what I'm walking along. That's my perimeter. If I move to the second stage, now it's broken into 3, and I have to do this 3 times, right? But each one of these is now just half, right? Because I've come down to half. So if I just take the triangle on the top, I'm walking half a unit, and another half a unit. I'm walking a half a unit 3 times, which means I have 3 half units. And I do this again for 3 triangles. So what do I have? I have 3 times 3 half units. That's how I came out with the second stage perimeter calculation. Let me put it in a way that makes a little better sense. I want to compare it to the first stage. Compared to the first stage, my second stage is 3 by 2 times the first stage. Or another way of looking at it is 1.5 times the first stage's perimeter. What do you think is going to happen in the remaining stages? Answers for, okay, someone has a 3 by 2 into 3, the whole power n minus 1, okay? Any other answers? 9 by 2 raised to the power of n minus 1, okay? 3 into 3 by 2, the whole power n, okay? Okay, good. It keeps increasing, that is correct. So let's go back to this figure. What do we have here? At each stage, your perimeter is becoming 1.5 times the previous perimeter. So you notice that the perimeter is increasing. That means if you're walking around the sides of the triangle, you're going to be walking more and more and more at each step. But what is interesting for me, and I think I have to rush, I'm not going to be able to show you how to do this on a spreadsheet, but I think this might be a fun thing for you to try out yourself, right? Here's what I would like us to do. Let's take a minute to understand what I have done here. You all already know how to do the stage column, right? I started with stage 1 and I did A2 plus 1 and I filled it out. In my spreadsheet, I actually had about 20 values, right? Then what did I do for number of triangles? I started off with 1 triangle. As you keep going to the next stage, what is happening? You're multiplying the number of triangles by 3. So I kept doing that on my Excel and let it do. And can you see how quickly the number of triangles is growing? Similarly, shaded area, I started with 1. And I know at the next stage, the shaded area is only 3/4 of the previous shade. So I did that calculation and I did a drag down and saw so many values. And perimeter, similarly, each perimeter is 1.5 times the previous perimeter. What is amazing about these numbers compared to what you saw earlier, you can see things growing very fast, right? If you see the number of triangles, and for me to be able to visualize this, I've used another feature of spreadsheet. I have actually created a chart. What did I do? I took the stage number and the number of triangles and created this first chart up here, number of shared triangles. In fact, when you look at this triangle, it looks like for the long period of time, it is actually 0. It is not 0. It's because the numbers are growing up so fast. Let me try to read what this number means. When you see a number like this, 1.25 e plus 9, what it means is it's about 1.2 followed by, it's a 1.2 billion. 10 power 9 is 1 followed by 9 zeros, which is 1 billion, right? That is the scale at which the number of triangles is just like exploding, right? This was, I think, within 20 stages, as you see on my graph. By the time I came to 20 stage, the number of triangles was in billions. If I look at the area, you can see we started off with area 1. And very quickly, by the time we come to the 20th stage, it is almost close to 0. You see that in the values in the table as well. This is only stage 13. If you go to stage 20, it's like 0.00 something something. It's getting very close to 0. And similarly, perimeter, you see it starts off with 3. And very quickly, by the 20th, goes up to 6,000 plus units. So the perimeter is also growing pretty fast, but not as fast as the number of triangles. You will notice that the number of triangles is growing like in billions, while the perimeter is growing in thousands, but this is still pretty fast too, because this is data only for 20 stages. and very quickly the area is coming up. This is a fascinating feature of fractals. In general, if you look up different shapes, different concepts related to fractals, this is one of the fascinating ideas related to fractals. If I were to teach you this only with numbers, I would say it gets dull very soon. But when you start putting it in spreadsheets and you start looking at the patterns so quickly, see what is happening so quickly, you start getting a sense of the power of using digital tools. Yeah? Okay. Sorry for rushing through the last one, but I hope some of you actually try this out, right? Try out what we did as physical calculation out on spreadsheets. Try to draw these charts for yourself and see what is happening. Okay. So quickly recapping what we did in today's session, we try to get a flavor of what is algebra, right? We try to see how we can generalize and understand number patterns, geometrical patterns, and how to use spreadsheets to do this too. If you noticed, when I type in formula, they are like algebra too. They are like algebraic expressions. When I'm saying is equal to a2 plus 1 is equal to a2 plus 1 divided by 3 and so on, these are algebraic expressions. So spreadsheets are giving you a way of learning to generalize and look at patterns. And that is algebraic thinking as well. And they help you do that with large numbers, right? So this is what we did today. I want to leave you with a very famous quotation by a very famous mathematician and teacher, Polya. Polya said that mathematics is not about numbers, equations, computations or calculations, or algorithms. It is about understanding, right? I hope in today's session, you got some sense of what it means to understand what is going on behind the screens, right? How to make sense of what looks magical or unexplainable up front. If you've got some sense of understanding what is going on below, that is awesome. Yeah, I will leave you with that now and wind up for the day. Over to you, Janani.
So much. Kanchana, that was amazing. Hey, wasn't it fascinating, guys? Who enjoyed the session? I want to see a yes in the chat. So we have 117 people. I want to see 117 yeses. Wonderful. I'm going to be walking around trying to look at the math and the geometry and the algebra of everything around me for the rest of the day. It's going to be so beautiful. Fascinating. So we have an announcement to make, guys. There's going to be an exciting moment. Oh gosh, it's going on and on and on. Super. We loved it, Kanchana. Beautiful. So guys, now second question. Okay, hold on. Hold your horses. Would you like to actually learn more from Kanchana? Is that something you would love to do? You want to attend more of these classes, learn more about how to look at math in this fascinating way? So we're going to put up a poll. Can you give me a response to that?
Yeah, that's about the specific course.
So we have this interesting course coming up and we want to share some details about it. I want Siddharth will be putting up a poll. Oh, wait. Okay, hold on. Let me give you a minute. Yeah, share your screen, Siddharth. So I'll share a couple of details about how you could actually learn more from Kanchana, and then you can get a chance to respond to that poll. So Kanchana is leading a course for us here at Gifted World, okay? From 18th to 26th of January, which is about a couple of weeks from now. She's going to be diving into a whole bunch of topics around this. So if you have more questions, you want to learn more, you want to find more ways of exploring math around you, then that's a lovely way of doing it. So classes are on Saturdays, Sundays and on Wednesdays, so you can do it around your school time also. We'll give you a coupon code for it, for being part of the masterclass. So this is called Finding X. So when you are checking out, if you want to use that coupon code to check out, you can do that. But we're only giving 10 tickets at this discount, okay? So there's quite a bit of you, more than 100. So if you're interested, it's a good idea to sign up immediately. So what we'll do now is we'll put up a poll. So if you want to, learn more about the course or listen to us more about it, then what you can do is you can put in your details and we can talk with you or your parents about it and see if you want to join the class. So it will be a small class where you can really talk to Kanchana and have a good idea of the different things that she's doing, right? So we put up a poll there. You have a couple of minutes to sign up. There will be 5 sessions where you can really sit and discuss things with Kanchana. We're talking about more about algebra and about math and how you can actually use different digital tools like Excel and few others that to make the job easier and more interesting for you, as we spoke about today. So this is a chance for you to get any questions answered. We have a few more minutes where Kanchana is here. And if you are younger than grade 6 and you're here, there's other opportunities, so you can fill in the poll as well, and we'll let you know if there are other courses that you can go to. Hey, so Viraj, thank you for the enthusiasm. But I think we can pause the chat now so that if anyone has any questions, they can respond. Vishan, yes, you can also join us. What we'll do is we will talk to your dad as well and make sure. Hamza, you can also join. I know you were there in the previous math course. So anyone who took Jayashree's math course last year, you are also eligible to join this course. Right? This will be a nice one to do it. You can't, even if you can't attend the session, Anushka, please feel free to hang on, because we'll get a chance to interact with Kanchana and ask a few more questions now about what she just taught us. If you don't have any questions and you're happy to log off, that's also perfectly fine. Shrihan, you don't have to decide now, but I would suggest deciding sooner rather than later if you want to use the discount code. And what you do is you just fill in the form and we can always talk to you later. Kaira, you didn't do it last year, you're in 5th. If you are interested, fill in the form and we'll talk to you and we'll figure it out. We'll see if you can follow the course content. Yes, the quotation was awesome. You're definitely right. Yes, Inian, you did it last year. This is a super course to follow up from last year as well. So you have a couple of days, Shrihan. Not a big hurry. You don't have to decide right now. You can reserve the coupon code Anai, so just fill in the expression of interest. If you didn't do it last year, but you're very interested in the course this year, no problem. Fill in the form and we'll get a response and we will see if you are eligible for it. Yay, Sridevi, glad you enjoyed the class. Anai, grade 7 is perfect. Grade 6 to 8 is the target, and if you're in grade 5, fill in and we'll talk to you later. Shrihan, fill in the form now if you're interested. Anyway, this is not a payment. This is just for you to tell us that you're interested in the course, and we will sign up for the course later after your questions are answered. You have an exam coming up. Oh, so sad. Well, we have multiple courses and masterclasses happening. So if you don't miss this, you'll have a chance again. But this is one great chance to interact with Kanchana. Great. Yes. Super. So if you love this masterclass and you want to keep coming to more interesting sessions, Siddharth is running one next weekend, and it's called How to Talk Like a Computer. So if that sounds fascinating, then join us. It's for anyone who's 10 and above. Yes, all the classes are on weekends except one Wednesday evening class at Dvaith. So if that works for you, then go ahead and put in the form. Yes. Wow, lots of yeses. Okay. If you're in grade 4, Aryan, try and join us for Siddharth's masterclass next weekend, and that is a course, that masterclass is free, and the course after that, if you're interested, is something that you are eligible for. Super. Thank you guys for filling the form. If you have specific questions for Kanchana now, based on what we all explored in the masterclass, can you put in your question in the chat and we'll call you up and you can have a conversation with her. Glad you enjoyed the class, Krishil. Yes, and the link to the masterclass is here in the chat. I'm going to put it again. Thank you for all the enthusiasm. You can leave now, Shrihan, if you have no questions. So, Diya, we're going to unmute you and you can chat with Kanchana. Kanchana, Diya has a question. Siddharth, can you invite Diya to unmute? I'm trying to find her in the list.
If she raises her hand, it will be helpful.
Diya, can you raise your hand so that we can find you nicely? Yes. Okay.
Okay, so can you just share the formulas again for the Sierpinski triangle thing?
Sure. So would you like me to start off with the number of triangles? No, the area and perimeter is what you're asking me, Dia? Okay, here we go. Do you have a specific question on how this came about? Or you just wanted to double check what you've done? Give me a second when I'll go switch on the background light as well. It's too dark behind me, I think. Just a Yes, Dia. Any follow-up questions? I'm not sure if you're on mute.
One second, Dia. You should get a chance.
Ma'am, I'm good. I don't have any more doubts in this.
Okay, awesome. So you should try this out on the spreadsheet, Dia. That's a lot of fun. I mean, the first stage is, of course, understanding what is going on here. But the reason I rushed through this is because I would like you to experience what happens when you work on large number of values, right? So please try to do this on a spreadsheet.
We're going to invite Gamma Yash Gorasia. Yash, you have a question, right?
Yes, ma'am. I had a question in the perimeter that when we in these all four diagrams, wouldn't the perimeter remain the same because the total area perimeter of the triangle is remaining the same. The small white triangle is inside the triangle.
It's a very good question. So when I ask you for the perimeter of, I'm not asking you for the perimeter of the triangle. I'm asking you for the perimeter of the black triangles, right? So if you see what is happening, the number of black triangles are increasing. So imagine you're actually physically walking along these triangles. So in the first figure, what you said was absolutely right. You walk along three sides and you're done. Correct? But if you go to the next figure, you're actually having to walk around three triangles. You're going to walk along the triangle at the top, then the triangle at the bottom left, and the triangle at the bottom right. Right? So when I'm asking you for the perimeter, I mean of the shaded triangles or the black triangles. And as the number of triangles increase, the number of triangles around which you have to walk is also increasing. And that's why the perimeter is changing as well. Does that make sense?
And in the original diagram of the whole shaded square which is provided, so if there over there, if you ask what is the perimeter, then over there it will come 3.
Yes, you're right. And so if you see in the first column of that table, I've written 3 because I'm assuming each side is 1, right? But if I go to the second one, correct? Now what has happened? How do you create those other triangles? By taking the middle point, the half point of each side. So what happens? What was 1 on this? Now this gets split into half and half, correct? Yes. And
Yes.
if I just take this triangle at the top, each of the sides is half. So just for the triangle at the top, what is the perimeter? Could you tell me?
The perimeter would be the first triangle at the top. The perimeter would be 3 and half multiplied by 3.
Half multiplied by 3. Very good. So you can think of it as 1.5 or 3 by 2. Correct? Yes? Okay. And then you have the same thing 3 times. You have to do this for these two triangles as well. So it's 3 times 1.5 or 3 times 3 by 2, which is what I've written out here. Can you see that? Now imagine going to the third step. Each small triangle of the stage 2 is becoming 3 smaller triangles, and you have to walk around each one of them. In this particular case, if you notice, each of those, it's too tiny for me to write, but I hope you can see what I'm writing. Each of those sides becomes 1/4, right? So try to draw this out and try to calculate what would be the perimeter of each of these tiny triangles. And how is it different from the stage 2 perimeter? Will you try this out? Yeah, thank you, Yash.